Now starting the second part, starting from the operators. These include arithmetic, logical, relational, equality, bitwise, reduction, shift operators, concatenation, replication and conditional. Here you see conditional interrogative sign with colon sign. Now starting from arithmetic operators, these include multiply, divide, add, subtract. This is modulus operator, and these two stars are used for power operation. Logical operators, logical negation, logical or, logical and. Logical operators, in these logical and logical or are binary operators, while logical negation is unary operator. Logical operators follow some conditions which include logical operators always evaluate to a 1-bit value which may be 0, 1 or x, also called ambiguous or unknown value. The second condition include if an operand is not equal to 0, it is equivalent to logical 1, true condition, and if it is equal to 0, it is equivalent to a logical 0, false condition. If any operand bit is x or z, it is equivalent to x, unknown value or ambiguous condition or value, and is normally treated by simulator as a false condition. Logical operators take variables and also take expressions as operand. Expressions in case of unary operator, which is logical negation. Here you see logical negation. Now these are some examples. Here A and B are given with the values. This is logical, and as this is not equal to 0, so it is logical equal to 1, and logical 1 and logical 0 equivalent to 0, logical 0. Here logical OR, it evaluates to 1, as logical A is equal to 1 and B 0, 1 or 0 is equal to 1, and logical negation A evaluates to 0 because it is equivalent to negation or not of logical 1, and negation B evaluates to 1. Now here A and B are given with A have unknown value. A logical and B evaluates to x because here due to x value, and A equal, these are the equality operator, evaluates to 1 if both A equal to 2 and B equality operator to 3 are true. Equality operators coming in the next slide here. Now next operators include concatenation and replication operator. This example you may first read equality operator from next slide and come back to this slide to verify it. Ultimately here it evaluates to 1 if here 1 and here also 1, then ultimately it is equal to 1. If any of these conditions are false, then ultimately this will equal to false. These are the symbol of concatenation and replication operators. Reduction operator include reduction and reduction NAND or reduction NOR. This operator is used for exclusive OR operation, reduction, and these are the reduction XOR. Both symbols are used. This reduction negation or negation reduction. X, both are used for XOR. Reduction operators take only one operand and it perform a bitwise operation on a single vector operand and yield a 1-bit result. The important point to note that reduction operators work bit by bit from right to left. Please note that starting from right bit values and ultimately go to the left values. Reduction NAND, NOR and exclusive NOR are computed by inverting the result of the reduction and reduction OR accordingly. Here are some examples. The value of X is given as 1010. Now a reduction operator is used, reduction and we have to start from right to the left, starting from 0 and 1 and 0 and 1. It results in 0. As you see, 1 and 0, 0, this 0 and with this 0, 0 and this and with 1, ultimately 0. Here, starting from here, OR operation is used and output will be 1. This is XOR starting from right to the left, result in 0. The application of reduction operator in exclusive OR or NOR gate include even or odd parity generation of a vector, as these are bit by bit. So these operators can be used for the circuit which include odd parity or even parity generation detection. Now the operator symbols are very much confusing. As for logical, these are used for bitwise, and reduction operators are also somewhat confusing initially, but the difference in the number of operands each operator takes and also the value of the results computed. These are some bitwise operators: bitwise negation and NAND, or this is for NOR, exclusive OR, and bitwise XOR. These are some examples here. X, Y and Z are given. This is bitwise negation X, and here we have unary operator, and each bit is negated 1 to 0 and 0 to 1, and bitwise negation result will be 4-bit 0101. Here this is bitwise, and please note that if this is double AND, then this will be logical. Now it is bitwise, and this X and Y are bit by bit ANDed, and result will be 4-bit 1000. Here bitwise OR is used, bitwise exclusive OR, bitwise exclusive NOR. The result should be verified. Here bitwise X and Z, all the result should be verified by yourself. Now these are bitwise operators and these are the logical operators. Logical operators yield always a logical value which may be 0, 1 or X, whereas bitwise operator yield a bit by bit value. Logical operators perform a logical operation and bit by bit operation, though those are different. Examples include X and Y are given. X or Y bitwise operation result is here, and this is the logical OR which have the logical output 1 or 0. As X is not equal to 0, so 1 logical OR 0 and result will be 1. Now equality operators, these include equality, inequality, case equality and case inequality. Now this table, in this table expressions are defined. This is equality operator and possible logic values include 0, 1 and X. This is, here you see inequality, A not equal to B, result possible values 0, 1 and X. This is case equality, A and B are compared including X and Z values and possible logic values are 0 and 1. Here case inequality, A not equal to B including X and Z and possible values are 0 or 1. Next examples are given. A, B, X, Y and Z, M and N are given. A equal to B. Here A equal to B. Here you see A is equal to 4, B is equal to 3, result will be logical 0. X is not equal to Y, so logical 1, because X is not equal to Y. X is case equality, here you see that case equal to M, but X is equal to Z. Z has some X value, so result will be in X, and Z case equal to M, you see that both are equal including last 3 bit XXZ and XXZ, so result will be logical 1, all bits match including X and Z. In this case equality you never find X or Z in the output, as you see here that 0 or 1 are the two possible logical values, but here in equality or not equality there may be X in the output. Here you see Z case equal to N. Here yes, these 4 bit 1 X, here X, but in Z value, here Z value, so these are not equal, logical 0 will be the answer. M is not equal, M is not case equal to N, here M, so this is true, so result will be 1. Now relational operators include greater than, less than, greater than or equal or less than or equal to. Please note the symbols of these operators. The expression returns a logical value of 1 if the expression is true, otherwise false. Let's see some example. If there are any unknown value or z bit in the operand, the expression takes a value of x. These are the same as the rule applying in the C programming languages. Here you see the functions exactly as C programming languages. A is given, B is given with 4 and 3 respectively values. X, Y and Z values are given. A is less than or equal to B. This is true or not true. This is not true. Evaluates to logical 0 because A is equal to 4 and B is equal to 3. A is greater than B. Yes, this is true. Y is greater than or equal to X. Yes, it's evaluate to logical 1. Y is less than Z. Here in Z an X value included, so the output will be X value. Now shift operators, these include unsigned right shift, unsigned left shift, signed right shift and signed left shift. You see that 2 symbols and here 3 greater than symbols, so this is differentiable. This is for signed and this is for unsigned. Also this is for logical shift and this is for arithmetic. Arithmetic shift always include signed right shift or left shift, and logical shift include unsigned shift. Please note the difference. Now let's see some examples. Arithmetic shift operators, because these are signed, so symbol is included. Let's see, here X is given and we want to shift, this is logical shift by 1 bit, so this 0 is shifted and here a 0 is appended, so 0 filled in MSB position and this 0 will be lost, so Y will be 0 11 0 and this 0 is truncated. Here X is logical shifted by 1 bit, so this 1 will be truncated and a 0 will be appended in the LSB position. Now here 2 bit of logical shift left, so this will be the answer. Now if integer ABC are defined with A0, because this value is integer, so minus number are also defined in the integer data type, and this is the operation A plus B arithmetic shift by 3 unit result in -2 decimal. Here you see this is -10 and this value should be in 2's complement form. Now you have to verify the result will be -2 decimal, and here it is also dependent upon the number of bits. Those may be 16 bit or 32 bit, and it depends upon this integer number of bits. Now these shift operators are used practically with shift and add algorithms for multiplication and other mathematical operations. Now we are going to discuss operator precedence. If parentheses are used and separate parts of expressions, then they should be followed. But if no parentheses are used, then a table is given here with operator precedence. It is recommended that parentheses be used to separate expressions except in case of unary operators or when there is no ambiguity. These are operator precedence starting from highest. Highest precedence include unary operator, and lowest precedence is for the conditional operator, and precedence this has the highest, and ultimately multiply, divide, modulus, add, subtract. In this order the precedence of the operator will be followed if parentheses are not used. So it is recommended that parentheses be used to separate expression to avoid any confusion. Now we are going to discuss some examples in data flow design. Considering 4 to 1 multiplexer, there are two methods in data flow to design 4 to 1 multiplexer: through logic equation or through conditional operator. Here a module mux 4 to 1 is defined with these parameters. This is for out and these are for input, and these are select lines. Here out is defined, input, these are the 4 inputs, these are also input select lines, and this is the logic equation. And through operators, these are negation and operators or operators we have implemented in Verilog 4 to 1 multiplexer. This method is through logic equation. Now another method, this method is through conditional operator, but both these methods are from data flow level. Here you see that same module multiplexer 4 to 1, input output are defined. Here these command out s1 logical operator conditional operator is used, and ultimately this 4 to 1 multiplexer is implemented in Verilog. So we have discussed about data flow design in this lecture. For any queries related to this lecture, you may contact on my email ID. Thank you.